Concept cars are designed to make you dream. Back in 2009, the BMW Vision Efficient Dynamics looked like one of those concept cars that would never leave the motor show. 5 years later, it became the BMW i8. So I wanted to understand how BMW pulled it off. One of the biggest differences between the Vision Efficient Dynamics and the production i8 isn't the shape. It's how much you can see through it. The 2009 concept almost feels like one giant glass canopy. The doors are largely transparent, the roof is transparent, and light floods the cabin. It makes the interior feel open, airy, and much more spacious than it actually is. So how do you even build a car like this? At first it looks like one enormous piece of glass. BMW used polycarbonate instead. It's much lighter than glass, and more importantly, it can be formed into shapes that would be incredibly difficult or simply impossible with conventional automotive glazing. The original Vision imagined one continuous transparent surface stretching from the very front of the hood all the way to the rear of the car. It looked spectacular. The problem is that road cars don't use polycarbonate windscreens. They use laminated glass. Glass offers better optical clarity, resists scratches from road debris, and years of wiper use. It doesn't slowly yellow under UV exposure, and perhaps most importantly, provides the rigid support needed when the passenger airbag deploys against it. Transparency looks fantastic, until it has to protect you. Imagine this car rolling over. The roof isn't just keeping the rain out. It has to support several times the weight of the entire vehicle. Now imagine a side impact. Those beautiful transparent doors suddenly need substantial reinforcement capable of absorbing enormous loads before they ever reach the occupants. So the moment a concept car starts becoming a production car, it needs somewhere to put all of that structure. The i8 isn't unique here. Let's look inside a typical modern car. You will find window regulators, side impact beams, latch mechanisms, weather seals, speakers, and wiring harness. Piece by piece, the transparency starts disappearing. And even on a carbon fiber car like the i8, all of this hardware still has to fit somewhere. Transparency also creates problems that have nothing to do with crashes. Where do the sun visors go? Interior lights, microphones, roof consoles. Running wiring through a largely transparent canopy is possible, but hiding it elegantly is another story. Then there's the sun. Today we have sophisticated infrared coatings, electrochromic glass, and all sorts of technologies that reject most of the solar radiation before it even reaches the cabin. Back in 2009, those solutions weren't nearly as capable. And remember, this entire project revolved around one word: efficiency. A giant transparent canopy might look spectacular, but thermally, it's working against you. Now let's discuss manufacturing. Imagine the tool needed to mold a single polycarbonate panel stretching from the very front of the hood all the way to the rear of the car. That's one enormous mold. It becomes expensive, difficult to manufacture, and difficult to control dimensionally. BMW knew all of the structural challenges, the material limitations, the thermal challenges, and the manufacturing challenges. And yet, when they returned with the second concept in 2011, they kept almost all of that transparency. This detail becomes important later in the video. Let's compare the concepts to the production i8. BMW wasn't simply changing the design. They were quietly making room for safety. And one of the first clues was hiding in plain sight: the seat belt. In both the 2009 and the 2011 concepts, the front seat belts are integrated into the seats themselves. At first it feels like the most elegant solution. It's clean, invisible, and it sounds almost obvious. Then the production car was presented in 2013. Suddenly, the seatbelt is no longer attached to the seat. It's now anchored directly into the body, just behind the occupants. And with that one decision, the rear access becomes noticeably more difficult. So why give up something that looked objectively better? Because the seatbelt isn't just a strip of fabric. Hidden behind the trim is a spring-loaded retractor. During a crash, the entire system has to withstand enormous loads. If the retractor lives inside the seat frame, the rails, and every mounting point suddenly become part of the restraint system. BMW chose another route. Anchor the retractor directly into the vehicle's primary structure, making the load path much more straightforward. But the trade-off is that you sacrifice some rear access. Not because somebody forgot about convenience, but because safety quietly won the negotiation. And the seatbelt is only the beginning. Look at how many passive safety systems are hidden inside the i8. There's a driver airbag, passenger airbag, curtain airbag running behind the A-pillar and headliner, seat-mounted side airbags, and even a knee airbag. Every one of them has to blend in with the rest of the interior. This is where the two concepts become really interesting. Let's go back to the 2009 Vision. The dashboard is extremely sculptural with sharp floating surfaces. The steering wheel is equally unique. Visually, it's fantastic, but from an engineering perspective, it's difficult to imagine how some of those restraint systems would actually fit. Then BMW comes back in 2011. The philosophy hasn't changed, but the interior has quietly evolved. The steering wheel now has a much more conventional center section, making room for a production airbag. The passenger side of the dashboard becomes smoother and more continuous, creating a surface that could actually allow an airbag to deploy safely instead of catching on aggressive styling. In short, the 2009 concept asks, what if? The 2011 concept has already started asking, how? Not by making the car less exciting, but by quietly finding places for all the things a production car simply can't live without. Looking at the vision efficient dynamics, one thing immediately stands out. The body feels incredibly clean. BMW wasn't just designing the body, they were also designing where your eyes would look. The easiest place to see it is on the hood. Those electric blue accents aren't only there to make the car look futuristic. They also distract your eye from the actual shut line running underneath them. Instead of following the panel gap, your brain naturally follows the color. It's a subtle trick, but an incredibly effective one. When BMW revisits the project in 2011, something interesting happens. The blue accents don't disappear completely. They're still there, but they're no longer hiding shut lines. They are simply part of the car's visual identity. The hood, however, loses them. And that raises another question. Why not simply keep the blue lines? After all, they were doing exactly what BMW wanted, making the shut lines almost disappear. The answer isn't really about styling, it's about manufacturing. There are essentially three ways of putting two colors on the same panel. The first is exactly what you'd expect. Paint one color, mask the areas you want to protect, then paint the second color. That's how many concept cars are finished, and it's still used today on some hypercars. Koenigsegg, for example, still creates many of its decorative stripes this way. The result is beautiful, but every single part depends on skilled manual work. That's perfectly acceptable when you're building one prototype or a handful of cars, but not when you're trying to build thousands. The second option is vinyl. Instead of painting the second color, you apply it afterwards. It's quicker, cheaper, and avoids another paint process, which is why you often see it on limited editions with racing stripes or decorative graphics. But in the end, it's still another manual operation. Somebody still has to align it perfectly. Then there's the third solution. Just don't paint two colors on the same panel. Split the colors in different parts instead. Now every component can be painted independently long before the car reaches the assembly line. No masking, no specialist labor, a process that's far easier to automate. And suddenly the production i8 starts making a lot more sense. The blue disappears from the hood because the hood becomes a single painted component. The blue survives where it naturally belongs, on separate bumper pieces. Not because BMW abandoned the original design, but because they found a much more production-friendly way of building it. Removing those blue lines creates another problem. The shut line still has to exist, but it just can't hide there anymore. So where do you move it to? BMW's answer is elegant. The split takes almost the shortest possible route between the headlight and the wheel arch, with another one appearing at the base of the A-pillar. The result is a hood that stretches almost the entire width of the car. At first, that feels like the obvious solution. After all, wouldn't fewer body panels simply be better? From a design perspective, it certainly looks better. But from an engineering perspective, that single decision changes almost everything. A panel that wide requires one enormous stamping tool. Keeping it dimensionally accurate becomes much more difficult, because even tiny manufacturing variations are amplified over such a large surface. That means more adjustment during assembly, tighter tolerances to control, and, ultimately, higher production costs. And the story doesn't end once the car leaves the factory. The giant hood is also one of the most expensive exterior panels to replace if it's ever damaged. A cleaner design today can become a much bigger repair bill years later. By the time the production i8 arrives, BMW adopts a much more conventional split strategy. Separate the hood, separate the fender, and separate the bumper. The front end gains more visible shut lines, but every component becomes smaller, easier to manufacture, easier to align, and significantly cheaper to repair. BMW wasn't just refining the vision-efficient dynamics. They were rethinking how the entire car should be built. The 2009 Vision doesn't actually share the same structure as the production i8. Its chassis is largely aluminium, while carbon fiber is mostly reserved for outer body panels. Then, somewhere between the first concept and production, BMW completely flips that philosophy. The body panels become mostly thermoplastic and aluminium, while the passenger cell itself becomes carbon fiber. That's not a small engineering revision. It's a completely different way of thinking. So why redesign the entire car? The answer starts with the battery. Today, we almost take electric cars for granted, but back in 2011, battery technology simply wasn't there yet. Carbon fiber is an incredible material, but using it on the exterior panels doesn't really take advantage of what makes it special. Those panels aren't really carrying significant structural loads. They're also the parts most likely to be scratched, dented, or replaced during the life of the car. So we have an expensive material with minimal structural benefit and difficult to repair. It simply wasn't the smartest place to use it. So BMW moved the carbon fiber exactly where it could make the biggest difference: the passenger cell. That's where stiffness matters. That's where crash performance matters. There's just one problem. Carbon fiber wasn't new. Formula One had been using it for decades. So did Ferrari, McLaren, Lamborghini, and others. They all knew how to build carbon fiber structures. But the challenge had always been manufacturing them. Traditionally, structural carbon fiber relies on prepreg. The fibers already contain resin, and every layer is carefully positioned by hand before curing inside a giant autoclave. The results are exceptional. With prepreg, some complex components still take days to manufacture. Koenigsegg's carbon fiber wheels are a great example. Perfect for a hypercar, but not so for a mass-produced car. BMW wasn't trying to invent better carbon fiber. They were trying to answer a different question. How do we make carbon fiber manufacturing fast enough and cheap enough for high-volume automotive production? Their answer became high-pressure resin transfer molding. Instead of starting with resin, they start with dry carbon fiber. The fibers are cut, shaped into a three-dimensional preform, and placed inside a heated steel mold. Only then is a highly reactive resin injected under extremely high pressure. completely impregnating the fibers before curing in just a few minutes. Instead of waiting days, a structural component leaves the mold ready for trimming within minutes. That completely changes the game. But every manufacturing process comes with compromises. One of the biggest advantages of traditional pre-preg construction is design freedom. Because every layer is placed by hand, engineers can easily create hollow structures and sandwich constructions using lightweight cores. They are incredibly stiff and incredibly light. HPRTM doesn't naturally favor those kinds of geometries since closed molds prefer simpler parts. So BMW had to solve the stiffness problem differently. Instead of relying on one large hollow shell, the passenger cell is built from multiple molded carbon fiber sections assembled together. Inside, additional carbon fiber reinforcement beams connect those shells, recovering much of the stiffness traditionally achieved with a single hollow composite construction. It's a completely different engineering philosophy. For a while, it genuinely looked like this was the future. Then the i8 ended production, and BMW quietly stepped away from full carbon fiber passenger cells. Today, BMW still uses it extensively though, in roofs, seats, braces and structural reinforcements, but never again as the complete architecture of one of its production cars. Saving weight made the i8 more efficient, while reducing drag meant BMW could make every kilogram they couldn't remove work just a little bit harder. So aerodynamics suddenly became just as important as lightweight construction. BMW often spoke about taking inspiration from nature, more specifically a falling water droplet. The i8 doesn't copy that shape literally, but you can clearly see the influence as the roof narrows towards the rear and the body seems carved away behind the cabin. Those flying buttresses aren't decorative fins. BMW actually removed bodywork to let airflow stay attached for longer before leaving the car. The result? A drag coefficient of just 0.26. Still impressive today, but especially for a production hybrid launched over a decade ago. But one feature stood out more than any other. BMW called it the air curtain. The wheels are one of the biggest sources of drag on the entire vehicle. For decades, engineers already applied one solution: wheel skirts. They work remarkably well, but they restrict steering, they limit brake cooling, and perhaps most importantly, they simply don't fit modern automotive design. BMW approached the problem from a different perspective. Instead of covering the wheels with bodywork, they covered it with air. Air enters through a narrow opening in the front bumper. Then it's accelerated before exiting through a thin vertical slit directly in front of the wheel. That high-speed sheet of air flows across the outside of the tire, almost like an invisible wall. It doesn't eliminate turbulence, it controls it. The underlying aerodynamic principle wasn't entirely new, but what BMW pioneered was making it practical for a production passenger car, turning an aerodynamic concept into something reliable, affordable, and manufacturable at automotive scale. Today, you'll find similar solutions on cars from almost every major manufacturer. Now let's look at the aerodynamic thinking everywhere else, starting at the front. BMW uses carefully shaped aerodynamic elements inside the front bumper to guide the air towards the radiators. It's directed upwards before exiting through the bonnet. Less pressure builds up inside the engine bay, cooling improves, and drag is reduced. Look underneath. The i8 hides almost everything behind a smooth underbody. Again, less turbulence, less drag, and more efficiency. These are exactly the kind of features you'd normally expect on race cars and hypercars, not on a production hybrid designed to drive to work every morning. Every one of these solutions added cost. BMW still chose to include them. By 2011, the vision-efficient dynamics already existed and the production car was well underway. So why build another concept? Because this isn't just another show car. It's the bridge between the dream and the production. BMW didn't abandon the original vision. It refined it. Look at the overall shape. The transparent roof remains, the transparent doors remain, the dramatic silhouette barely changes. But while the overall vision stays remarkably faithful, the details quietly begin to evolve. The headlights grow slightly larger. Not production headlights yet, but no longer as extreme as the 2009 Vision. The mirrors move from their dramatic high-mounted position to the base of the A-pillar. Still incredibly slim, but now much closer to where they'll eventually appear on the production car. The front bumper opens up, feeding considerably more air towards the radiators. A reminder that this car isn't just about looking futuristic, it still has to cool a real powertrain. Even the blue accents begin to change. On the 2009 Vision, they disguise the shut lines running across the bonnet. By 2011, those lines disappear. Instead, the blue graphics move towards the kidney grills and lower bumper. Exactly the approach BMW would later use on the production i8. Around the rear, the same thing happens. The blue accents stop hiding construction and they begin defining design. Looking at the interior, the steering wheel now has a proper center section. The passenger side becomes far smoother and the dashboard begins respecting the packaging needed for airbags and other production hardware. Nothing feels accidental. Every change makes the car slightly more believable without making it feel ordinary. And that's what makes this concept so relevant. It isn't replacing the 2009 Vision, it's translating it. Not for the public alone, but for BMW itself. The engineering team now had a concept that already respected far more of the production constraints. The designers still had a car that captured the original emotion, and everyone watching could slowly adjust to what the production i8 was becoming. While the exterior still had the freedom to dream, the cabin had to start answering a much more difficult question. How do you turn a concept interior into something people can actually use every day without losing what made it special? One of the clearest examples is the instrument cluster. The Vision Efficient Dynamics doesn't use a conventional display at all. Instead, BMW projects the information onto a transparent panel sitting behind the steering wheel. By the time the 2011 concept arrived, however, that projection had been replaced by a proper screen. The information was still fully digital and the experience was still modern, but now it looked like something you could genuinely imagine seeing in a production car. The center of the dashboard follows exactly the same journey. In 2009, there isn't even a proper infotainment display. The dashboard behaves almost like a single sculpture, large flowing surfaces, very few interruptions. Nothing that immediately looks like a radio or a navigation system. By the 2011 concept, BMW quietly introduces a central display. Not quite the production system yet, but clearly moving in that direction. The same happens lower down. Climate controls begin to appear, real switchgear starts replacing abstract design, and little by little, the cabin begins accepting reality. And then there's something even more ordinary. Air vents. Looking at the 2009 concept, it's surprisingly difficult to work out where the air is actually supposed to come from, if vents exist at all. BMW certainly doesn't want you to notice them. And that's perfectly normal for a concept car. Concepts don't always answer every engineering question. Sometimes they simply explore an idea and assume the technology will eventually catch up. By the time we reach the 2011 concept, the vents finally appear, and they don't try to hide. They are large, highly sculpted, almost becoming part of the dashboard design itself. Only the production i8 eventually transforms them into something much more familiar. Still beautifully integrated, but now clearly designed to move air first and decorate the dashboard second. The steering wheel evolves in much the same way. The 2009 concept is incredibly clean. There are no buttons and there's no obvious place for driver's airbag. By the time BMW unveiled the 2011 concept, the steering wheel had gained a much more conventional center section. BMW wasn't replacing one interior with another. It was gradually increasing the maturity of the same idea. When BMW unveiled the Vision Efficient Dynamics in 2009, it wasn't even petrol-powered. It used a tiny 3-cylinder diesel engine. That sounds almost absurd for a sports car. But the electric motor could provide instant torque where diesel couldn't. Together, they complemented each other surprisingly well. By the time the production i8 arrived, the diesel had disappeared. In its place was a 1.5-liter turbocharged 3-cylinder petrol engine. The philosophy hadn't changed, only the execution. A smaller engine is lighter, consumes less fuel, produces less CO2, and with electric assistance filling the torque gap, BMW could still deliver the performance expected from a sports car. And yet, the production i8 spent years being criticized for having only 3 cylinders. Which is funny, because when Koenigsegg revealed the Gemera in 2020, another hybrid performance car built around the 3-cylinder engine, the engineering world loved it. Of course, they're different engines. Koenigsegg's free-valve technology is an incredible piece of engineering in its own right. But the underlying philosophy is surprisingly similar. Use a smaller, lighter combustion engine and let the electric motors do what they do best. BMW had already been thinking that way more than a decade earlier. The battery packaging tells the same story. Most hybrid and electric cars place their batteries underneath the floor. But it also raises the seating position. BMW did something different. Instead of spreading the battery across the floor, they packaged it inside the center tunnel. Immediately, the driver and passenger could sit much lower as you're sitting beside the battery instead of on top of it. That doesn't just lower the center of gravity, it also allows the entire car to be lower. Less frontal area, less aerodynamic drag, and once again, one engineering decision quietly solves several problems at the same time. Looking back today, the i8's architecture almost feels unfinished. Imagine the same recipe today, with a modern 3-cylinder producing around 300 horsepower, electric motors adding another 300, and more than 100 kilometers of electric range, all packaged inside a lightweight carbon fiber sports car. And suddenly, the i8 doesn't feel like a failed experiment. It feels like a car that simply arrived 10 years too early. The best production cars aren't the ones that preserve every detail. They are the ones where the original vision survives the journey to production. And after going through everything that changed, I think that's exactly what happened here. The i8 wasn't BMW getting everything right. It was BMW asking difficult engineering questions years before most people realized those questions even mattered. Looking back now, I think that's what makes it such an interesting car. If you've made it this far, thank you for watching, and I'll see you in the next one.